Hey there. So here's a 3D printer that we're running. It's a Creality CR10s. The reason I really like this one is because of the large build size. It's a significant amount of printable area, which is really great for being able to do multiple prints at the same time. That's exactly what we're doing right now. As you can see, this is the Montana mask. I'm printing 3 of them at the same time. This basically is going to run out to about 14 hours. So this is going to be going overnight. It's going to be ready about tomorrow in the morning. And it's to give you an idea of the time scales. Just the mask by itself, usually 7 to 8 hours. The face shield usually 4 to 5 hours. So being able to print multiple objects at the same time is really critical. And having that large size really goes a long way to making this an efficient mass production process. We're all based on PLA plastic. It's biodegradable. It's strong. It supports the materials really great, so it makes printing a lot easier. And we're using just a micro SD card to transfer data back and forth and being able to get these models printed out. So basically, once you've assembled and set this up from where you purchased it and leveled out the bed, make sure that it's nice and flat to be able to do accurate printing. The process is basically you search online for 3D file formats that allow for 3D printing. Thingiverse is a really popular website for getting 3D models. NIH, as I've mentioned before, has really accurate, medically approved models, which is very important. You usually get these as STL files, which are kind of general purpose 3D files. Using software called the Slicer software. In this case, I'm using Cura 3D, which is open source, free, and it comes from Ultimaker. Slicer software basically takes geometry, 3D topology, and translates that into buildable 3D printing layers, and basically slices it into all the components necessary to print it as a physical object on kind of any number of 3D printers, and this is a very critical part of it. So using Cura, you basically kind of adjust the settings on it. It's really critical to play between properties of material strength, material surface finish versus build time, and trying to get something that is as sturdy and robust as possible in the least amount of time. It takes a little bit of tricking with the settings, and there's a lot of settings, and I could go into detail in another video about kind of what is required for really efficient printing settings. Once the slicer is ready, then it provides the G-code. Take that, you put it into the main processor, load up your settings, and make sure everything's calibrated and running right, and run your print. And usually it takes anywhere about 3 hours to as high as 24 hours for some of these prints. So there's a lot of difference in terms of like what kind of your throughput is in terms of your manufacture process. It's really critical also to be aware of safety, especially starting out. You want to keep eyes on this. We've had a situation here where we had a fire from one of the extruders, which is a possibility. These are industrial machines, they're not toys. So it's very critical to keep an eye on them, even throughout their long build time. It's always good to check on them, at a set pace, and have a timer to, remind you to keep on checking in. And also have a really flat surface, really helps out. This is actually a pretty substantial metal case here where it's going to be able to support kind of the movement and still have build accuracy. Other areas of concern is also pretty much the materials they're using. Currently we're using PLA because these are like mono-piece kind of objects that we're building all kind of in one go. Some of the other devices that I'm planning on designing, kind of full face respirators and ventilators, kind of at the same time require somewhat of like soft plastic for molding onto the face. So actually I'm getting flexible TPU plastic coming in that will allow for these kind of more soft face skin molds for the larger helmet-sized devices that I'm developing as we speak. Hairspray, really important. before you build, you got to spray on the plate. That's what keeps the object on there. I know it sounds goofy, but that's really how we roll in here. So basically, the purpose of this video, I kind of wanted to give big picture orientation of kind of what 3D printing is like, what the manufacture process is like, what does it entail, to give the public an idea of what this is like, and that not to be afraid. This is something that just about anybody can do once you understand kind of the science and the mechanics behind it. And I think this is really necessary because the demand and need is very serious. The healthcare professionals really need this stuff, and it's really a life and death issue. So it is critically important that we all come together and do whatever we can to build and manufacture as much as we can. If I had more of these 3D printers, the output of what I'm building exponentially increase. Donations are very helpful and very appreciative, but also expertise, logistics, resources, anything that you can contribute to make this response even better really makes an enormous difference. If anybody's out there watching this has kind of any questions, please feel free to comment below. Send out private messages. Feel free to reach out to me. I'm very open to any kind of suggestion, questions, or advice, or any kind of suggestions anybody could actually give to make this process any better. Definitely welcome. If you're a medical expert, please let us know how we can contribute, where we can deliver, what hospitals or spaces you need this at. We're here to serve the public. I've had many people, out in person, seeing me wearing the mask, or online, knowing, this kind of project that I'm on, have been asking me, to buy masks or, to purchase them. And it's like, no, this is for the public good right now. It's not a matter of economic self-interest. It's not a matter of, commerce. It's really a matter of just basic society, us coming together and confronting a collective threat to our human existence here in the United States of America. And this is something that, I can't emphasize how much we need to be working together. We need to do everything we can. I know everybody's in quarantine, but absolutely, this is something that we can be doing. And people need this. Again, vulnerable populations are the one most affected by the coronavirus. And we can do better in making sure that they're safe, that they're protected. And in protecting others, it's also, protecting ourselves. Reducing transmission of the coronavirus will reduce the infection rate, will reduce the danger and lethality of the pandemic, and ultimately it will reduce the amount of time that we'll be in quarantine. We'll suffer these grave economic, consequences that we're going through. So that's about all. I'm really positive about the outreach that we've gotten so far. There's an enormous community out there. There's tens of thousands of people all collaborating and working, from individuals to businesses of every kind of size. They're all doing their part, and this is really great to see, and it's very uplifting and inspiring. It inspires me to do a lot of this work, and I hope this message can reach out to as many people as possible. And like I said, if anybody needs any kind of help, let me know, let the community know, reach out. We can beat this. We will beat this, and we will be better, and we will be safe, and we will be with our loved ones, hopefully all safe. Continue in the quarantine, and good luck.